Hey everyone, thanks for coming today and participating in this second lecture as part of our deep learning course. Today I'm going to talk about getting started with digits. And to start out, I'm going to give you a brief introduction to digits and image classification. I'll go over a little bit on how to install digits and how you get digits, and then I'll talk about creating data sets, training your network, and modifying your network. And there's a hands-on lab that coincides with this lab, and so when I talk about how to use digits and how to make these changes and how to create a deep neural network for your data, I'm going to talk about it in the same. I'll have the same steps that go along with the hands-on lab, so you can use this document as a reference. So what is digits? Digits is an interactive deep learning GPU training system. It's interactive and it's a great visualization tool. So every step of the way there are features and visualization capabilities to help you monitor and keep track of what you're doing. So when you first pull in your data and into digits and you want to use it for training, when you're processing your data, digits will show you information about your data set. So as you start developing a neural network and as you start going through this whole process of deep learning, you'll realize that you'll have a lot of different data sets, and you'll even have one data set where maybe you've got 5 or 6 different variations of it. And the nice thing about digits is it shows you when you have a data set, when you pull in your data and create a data set, it'll show you information about that data set, how many categories you have and how many images in each category and so forth. Then when you are ready to configure your deep neural network and start training, there's another interactive page that helps you configure your deep neural network and helps you decide how many GPUs you want to use for your training and helps you decide what type of solver you want to use and the learning rate and so forth. And then once you've got everything configured, digits will show you in real time what your performance is, what your accuracy is, and your loss, and what your learning rate is. And then it will also let you visualize your network responses. So when you start training or after you're done training, you'll want to do some classification, maybe with single images or multiple images, and digits allows you to do that too. And the last image on the right here shows an example of classifying an image and network and the responses you'll get from your network, the weights and the activation. So who is it for? Well, anybody who wants to explore neural network for their data set. It's what I'm looking for. And the idea and the whole premise behind digits is this is a tool, an interactive tool, a visualization tool that allows you to quickly develop a deep neural network for your data and allows you to easily explore deep neural networks with your data, right? Because there are a lot of neural networks out there, and you may want to take your data and experiment with different neural networks and see how well each neural network performs with your data, things like that. So digits is really good for that. So anybody interested in doing that can use digits and help them do that. It's also great for handling your GPU resources. So if you've got a multi-GPU machine, it can be used to do multi-GPU training where you're using multiple GPUs for a single training, or if you're running multiple trainings in parallel, you can also manage that with digits. So if you have 4 GPUs, you could assign a training to each GPU, or if you're doing multi-GPU training, then you can have all 4 GPUs being used for a single training. Okay, so what is deep learning? And I know many of you probably participated in the previous class, but just in case there are a few people on the call who didn't participate in the last class, I thought I'd have just a brief example on what is deep learning. And in this example, I'm just using a digits data set. And this is a simple classification example. In this case, it would be for images as your input. And as you ingest data through your network, the responses of the network convolved together tell you what the input is. So if I push an image of a 7 through my network, hopefully my output, ideally what your output will tell you is that, okay, I know that image was a number 7, or a number 1, or a number 2, or a number 6. And then the deep neural network is really interesting because it's a multi-layered process. And at each layer, in this case, you're having some feature abstraction being performed. And it's the convolved response through the network that tells you, okay, I know what this is based on what I've been trained on to find.
Hey, Allison, hate to interrupt you. Can you mind speaking up a little bit? Some people are having trouble with the audio.
Is this better? Is that audio better?
A little bit. I just try speaking louder if you can. That'll probably help.
Okay, I need to, all right. Hopefully this is better. Otherwise I can switch to a headset. Okay, so image classification with DNNs. Here's just another example slide that shows you what the process is. When you think about wanting, you've got data, you think about wanting to apply it to a convolutional neural network and see if you can use this large amount of data to get intelligent information out of it or perform classification. When you think about applying that data, there's a couple steps involved, right? First, you have this training process, and the training process is where you take some type of network configuration and you use that to train, and over time, that network will be fine-tuned to your data, right? It will be, after you're done training, ideally, it will be able to accurately classify and categorize information that you've been trained to, you want to train it for. So in this case, for digits, maybe my input information in this example is a series of numbers ranging from 0 to 9. And when I'm training, I'm going to push this through my network, push this data through my network, and over time, these weights in this network will slightly adjust, and weights will update and be nudged so that classification is able to classify and say, okay, this is a 0, not an 8, or this is a 2, not a 3, things like that. And then I'll have this separate data set that isn't used for fine-tuning or modifying or teaching my network to accurately classify this data. It'll be pushed through the network, and it'll be used to tell me what the accuracy is of my data. And I'll use it as my metric for performance. And this is really helpful because deep neural networks are prone to overfitting. So what can happen is they can become overfit, and that means that they become incredibly effective at identifying their training data, and then but then they're not great at identifying other things from the same category, things that are objects and information that it hasn't seen, that isn't part of the training set. So it's really important to have this validation data set to help quantify and test the effectiveness of your network. It also can help you say, okay, I've been training for a while, and maybe my performance isn't good. It isn't very high. My accuracy is really low, and I've been training for a while. And you say, okay, well, I'm just going to stop my training, and I'm going to take a look at my neural network, make some adjustments, and then I'm going to retrain again. And Digits makes all of this really easy. I'm just giving you a little background on it, and then I'll talk about how you use that for Digits later on in this presentation. So how do you get Digits? Well, there's a couple ways to get Digits installed on your system. The really easy way is to use our web installer, and the web installer works with Ubuntu. The not as easy way is going to be on a Mac or Windows, and Windows is untested. So the main thing with Windows is that you'll have to, and even with OS X, when you're not using Ubuntu 14.04, you'll have to build NVIDIA's Cafe branch and then use Digits. So just remember to use NVIDIA's Cafe branch because that's officially supported by Digits. As far as hardware-software recommendations go, if you want to use cuDNN, make sure that you have GPUs in your host machine with compute capabilities greater than or equal to 3.0. Also, the easy way to install it, of course, is with Ubuntu 14.04, but it'll also work with other variants of Linux, like CentOS and so forth. Okay, so I'm going to talk about the hands-on lab, and I'll talk about Digits. And as I talk about Digits, this is a guide for how you will go through the lab. So you can use this as a reference documentation, as PDF for reference while you're going through the lab. So I'm going to talk about quickly training and improving your deep neural network well suited for your data. I'll talk about creating a database, starting out with a standard network, and ways to modify your network, and then adding and removing parameters. So we talk a lot about how easy it is to tweak and modify your network, and I'll give you a couple examples on how to do that. And then I'll talk about augmenting your data. So creating a data set. When you start, the first time you open up Digits, this is what you're going to see. You're going to see this main console. And this is like your center dashboard. This tells you what data sets and what trainings you've performed on this machine or on your host machine. And it helps you keep track of things. So it'll list off all the data sets you've created, and it'll list them off by name, however you name them. And then the models will show so all of your models and how long they've been trained. Or it'll also post this if you stopped a training, if you aborted it, or if there was an error. So to get started, before you can start training, you will create your data set, and you'll put it into a format so it can be ingested by the neural network for training. And one thing to think about when you get started is what format your data should be in. So there are a couple ways to have your data before you ingest them into Digits, and this is the easiest way to do it. I use this approach all the time. I'll have a main directory with all my images, and then within that directory I have all these subdirectories. And the title of these subdirectories are the names of my categories. So in this case, if you're using Digits, or a series of digits, category 0 will be for all of my zeros, and within that directory I will have all my 0 images. And then I have another directory for ones, and then I will have images for all my ones there, and so forth. And I'll go through all my categories like that. And what happens is then you'll use this Use Image Folder tab in your new image classification data set, and you just put the path to your images. And Digits on its own will say, okay, I know that each category within this path, or each directory within this path, is a category, and I will label it that way. Then we talked about having I talked earlier about having a training set, and then having a separate set of data that I will use to test the accuracy and the effectiveness of my network, and that's what the validation is for. You can also do testing if you want, and it just makes it easy to do that here within this user interface. And you can just select what percentage of the data will go towards validation here. Also, if your images are different sizes, if your input images are different sizes, you can have them all resized to the same image, to the same size in this console too. And you can do cropping, you can do various image resizing, and you can also specify if your input data images are color or grayscale. So once you create your data set, and once you say, okay, I've inserted my path, and I've given it a name, I've decided on how I'm going to resize my data, okay, now I'm ready to resize it, and I'm ready to create this data set. Digits will tell you a lot of information about your data set. It'll tell you how many images you have in each category, and it'll list all of your category names for you. And this can be kind of helpful. So once you start using Digits and you've got all these variations of your data sets, it's really nice to be able to just look at your data set and then know, okay, I know this is this data set because here's how many images I had in that data set. It's nice to also just be able to look at it quickly and say, hey, I resized this to 28 by 28. That wasn't the the data set I wanted to use. I wanted to do 256 by 256. So it's nice that it gives you a quick overview of what's going on in this data set, how many training and validation images I have, the number of categories, even my folder, where it's located. All that information will be really helpful. Also, it'll post information about when this job was run, and then if you had any errors. So let's say you put in a path that has a typo in it, and it's a path that doesn't lead anywhere, all those errors will post right here. Digits will continue to run. All you have to do is go back to the main Digits console and then re-enter the path, the correct path, and it'll be fine. Digits will not crash on you. So just to kind of reiterate what your training and validation data is, so just remember that it's important to have that validation data, because when you train a neural networks are prone to overfitting. And so just remember that you're going to have the training data is used to teach the network to classify your object categories, and then the validation data tests the performance of your network, and that's why you have them both. So your training data is the only portion of your data set that's used to fine-tune and modify and tweak and improve the effectiveness of your trained neural network, and then you'll test everything with your validation data. And since validation data is prone to overfitting, or since your neural network or while you're training during this process, overfitting tends to occur. The validation data is really great for helping you identify when this happened and saying, okay, I know I started to overfit at this point. I want to use my trained neural network at this point because I wasn't overfitting here. My network wasn't overfit. So once you have your data set created, now you're ready to configure your neural network, right? And one thing that I do is start with a standard network, but you definitely don't have to do that. But in the hands-on lab, in this example, I'm just starting with a standard network configuration just to get started. Just because I feel like the first time I get data and I want to test it, I tend to just start with a standard network to see how well it performs, and then based on that, decide what I want to do, whether it's tweak that neural network or try a different one or modify my learning rate or do a variety of things like that. And so that's how I started this out, just because that's how I usually use digits. So in this case, when you go to this window, you'll see the Standard Networks tab is the default tab, and you'll see a list of standard networks. You'll have LaNet, you'll have AlexNet, and you'll have GoogleNet. And feel free to start out with any of those networks. One thing to keep in mind is the intended image size. So if you were starting with the LaNet data and you started with the LaNet digit set and your input images are 28 by 28, you're not going to be able to use them with AlexNet when the images are that small. You'll have to make sure that your images are 256 by 256 to run. So those are just a couple things to keep in mind. Okay, so a network configuration. Here's LaNet, and I highlighted it in the previous slide just because I wanted to talk about it here. One thing that I feel like is important, especially when I choose a network and then if I think that I might want to modify it, one thing I think about, or one thing I try to think about is what's going on with my network? What does my configuration mean? If my input size is 28 by 28, what happens to that data as it gets pushed through my network? When I apply my convolution, is my input, when I apply my convolutional layer, does my input, the response, my feature maps, does it reduce in size? And in some cases it does. In this case, for the LaNet network, it does. It gets reduced by 24 by 24. And as you push things through your network, things get further reduced, right? So subsampling is a step by which the dimensionality of your input image is reduced, and it can be reduced by half or even more in some cases. And then I'm going to talk a little bit about that more in this presentation as well. So these are just some things to think about when you want to select your network or make some modifications. So when I select a network, I like to go to Customize, and I love to select my Visualize button on the Customize tab just so I can see what my network looks like. And then I can see, okay, I have my MNIST data. I'm going to push my data through, and I can see, okay, here's my convolutional layer. Here's information about my kernel size. Here's information about my stride. And then from this layer, I have 20 outputs. And that tells me a lot about what's going on with my network configuration. So let's take another close-up look at what this means. So I showed you the LaNet network a few slides ago. Here's an input image of the number 8, and after I push this image through my network, here's how it relates to the network configuration that you'll see when you visualize. Convolution 1, my output's 20, and here's this. And then when I want to pool, here's how that network configuration relates to that schematic that you'll see when you visualize your network. And this is helpful because maybe you wanted to have more outputs, right? And if you wanted to have more outputs for that network, you know that you would make that modification to your convolutional output here. Okay, so there are a variety of, I know I've been talking a lot about looking at your network and looking at your layers and how you relate your network configuration to the visualization tools within Digits, but there's also other features too. There's a lot of knobs when you want to train a neural network, and there are solver options. So I'm going to talk really quickly about solver options here. Training epochs. How long are you going to train your data? And an epoch is, well, a single epoch is equivalent to all of the data being ingested by the network one time. And then your snapshot. So the snapshot, just like when you're using some of these other frameworks out there to do deep training, you'll be training for a long time in some cases, days or even weeks. And what a snapshot does for you is it's a point during your training where your trained neural network has been saved. So you can go back to that trained neural network and launch it and use it, deploy it. Or if maybe your system went down, you can always go back to that network and then retrain from there. Then your validation intervals. So I talked about using the validation data to test the accuracy and the effectiveness of your trained network. And this is where you can decide at what interval you do that. What's your cadence for testing that? You can decide the batch size, and that's the number of images being processed together. You can also choose your solver type, and you can also choose your base learning rate. So once you start training and exploring ways to develop a deep neural network, you'll have the opportunity to play with all these things. I find that when I'm doing my base learning, the first thing I usually modify here as far as these parameters go is usually my base learning rate. So a lot of times I'll start a training process and maybe I'm not learning at all for whatever reason, or maybe my losses are diverging or increasing. Usually the first thing that I look at is my learning rate, and I'll reduce that to see if I can improve my training. Okay, so I gave you a little bit of information about that. Now I want to talk to you really quickly about GPUs. So another thing that's really nice about Digits is that it makes using the GPU, it's really easy to use the GPU with Digits. So if you have a single GPU system, no problem. Digits will run with that single GPU and assign training to it. If you have multiple GPUs, the nice thing about Digits is you can decide if you want to use one GPU or if you want to use more than one GPU, but you can also decide which GPUs you want to use. So maybe you have a system with different GPUs in it, maybe K40s and some K80s. You can decide which GPUs you want to assign a specific training to. Okay, so training results. So once you start training your data, and once you start running through, you've got your data set, you've decided on a network configuration, you visualized your network, you're ready to start training, Digits will show you right away what the accuracy and the performance is. So this makes it really easy to say, okay, my performance is poor, I'm going to abort, modify, retrain, or say, hey, my performance is really good, I'm going to let this finish and then test this out and deploy it. And another feature here is that while this is training, I showed you the main Digits dashboard earlier. The nice feature here is that the nice thing about Digits is that when you go to your main Digits console, even if you're not on this page viewing your accuracy, it will tell you that something's running. So you know that somebody or you have a job running on your host machine. Or maybe you ran a training the night before, you can go right to Digits and say, okay, I know it's still running, no problem. And then you can connect right to this page and see what the status is at any time. Okay, so I talked a lot about overfitting, and I talked a lot about why you have this training and validation set. And I thought I would have a slide here that just shows you and tells you what that means or what that looks like. How do I know that's even happening, right? You tell me that overfitting, like neural networks are prone to overfitting. Okay, great. So how do I know when that's happening with my data or during my training? And how can I tell using digits? So here's an example of overfitting. Here's a example training results that I have on some data that I grabbed, and it's some data of shifts. And what you can see here is that this green line tells me what my losses are. And once that green line started to increase, I started to overfit my data. And that's fine. So now I can look at this data, and at a later date, my training's clearly done. I'll go back to this training exercise, take a look at this job. And I say, okay, well, I really like this. I really want to test this neural network out. So I'm going to deploy or test my neural network at this snapshot. And in this case, it's going to be at epoch 12 or at epoch 10. So I'm going to grab this snapshot from epoch 10, and I'm going to use that. I'm going to grab that from digits and then deploy that version of it. Also underfitting. So maybe your loss isn't increasing or your accuracy has flatlined and things aren't going well. You can use digits to visualize that too and say, okay, this is not going well. I'm going to abort or stop my training and go back to my network configuration, try and make some adjustments, or maybe I'm just going to try adjusting my learning rate. Okay, so single image classification. So one thing to keep in mind with digits too is that you use this tool to visualize the accuracy and the performance of your network, but you'll also want to say, okay, well, let me just test some images. Let me perform some classification, and let me see what the response is of my network, right? Because that's really, people talk about these deep neural networks and these convolutions, and we talk about these feature maps, but it's really hard it can be hard for me personally to visualize what that means and what's going on to my network. And so I find this feature really nice in digits. So as soon as you start collecting snapshots, you can start performing classification and view your trained neural network's response at that point in time in the training. You can view its response to input images and information that it has or has not seen before. And you can decide, right? So when you do this spot classification like this, you could take an image from your training set and classify, or you can take an image from your validation set, or maybe you have images that are not part of your training and validation set that you would like to use for classification, that you're hoping your trained neural network will be able to accurately identify. So at the bottom of your training page, where you've got where your network is trained, and it'll show you the plot of your accuracy and your losses. At the bottom of that page, you will be able to see a series of options for doing classification. You can put in an image URL. You can upload an image locally from your machine. If you're running digits on a remote machine, you can upload it from your local machine to that machine, or you could just upload it from the same host machine if that's what you're running on. You can also upload an image list and classify many images, and you can show a series of classifications. So maybe you have a list of a couple hundred images. You can run that through digits really quickly as well. So here's some sample image classification results. And digits will show you distribution information like with the mean and standard deviation for each of your layer parameters, but it will also show you what your network responses are. It will also show you the weights. So it'll show you the weights for each of your convolutional layers, and then it'll also show you your activation. So you can view what the network response is from that input information. Okay, so I thought I'd have a couple slides here that show you how you relate your network configuration to your responses. And I thought I would include this here because when you think about tweaking a network and adding and removing layers or outputs or changing your kernel, I feel like it's just important to relate what your network configuration is to how you use digits so that you can use digits effectively, right? So you've got a network configuration, I visualize my network, but how do I know what that means, and how do I know what it's doing? So here's just a slide that shows, okay, here's the one network again, and when I talk about feature maps and responses, here's an example of what they would look like. So here's my network configuration. I've got a trained network on my digits data set. I grabbed an image, input an image of the number 8, and I pushed it through my trained network. And here's how my responses relate to my network configuration. And here's when somebody talks about a feature map, here's what that means. Or when somebody talks about pooling and subsampling, here's how that looks. So if I have an input image that's 28 by 28, I apply a convolution, and my feature map, after going through the convolutional layer, my feature map dimensions are 24 by 24. Here's an example of what that would look like. And then when I subsample and reduce the size of my feature maps in half, here's an example of what that looks like. And then if you push it through another convolutional layer, here's what that response looks like. And then after subsampling again. So you can see how this information is ingested by the network and what the network's response is. And it's really interesting to see if you want to compare the responses of different input images to see, okay, here's what my responses look like for an 8, here's how different they look when I push a 1 through it, or maybe they look very similar in some cases, right? Yet the network is still able to accurately identify and say, oh no, this is an 8 or this is a 1. Okay, so I've talked a lot about network configuration, and I talked a lot about how you relate it to how you can use digits to help you visualize your network configuration, and then what those, when you want to classify and you want to look at the response of your network, how that relates to your network, so you can get an understanding for that. And then once you get to that point, right, you say, okay, well now I'm ready to make some more modifications. How can I make some modifications to my network to see if I can improve performance? And there are a lot of parameters that there are a lot of knobs to turn in a deep neural network, right? You can add a layer, you can add pooling, you can change your activation functions, you can zero path. So maybe if you didn't want to, if your input data was 60 by 60, you're going to apply a convolutional layer, but you don't want to reduce the size of your feature maps through that convolutional layer, you could zero pad. And I'll talk a little bit more about that in the next slide. So in this case, here's an example where I would like to add a convolutional layer, and I'm going to say, okay, part of adding this layer, I'm going to increase the size of my input data. So my image will now be 60 by 60 pixels when I push it through my network. And I'm going to apply a convolution, and I'll apply some subsampling or pooling. And here's an example of how my new neural network would look if I did this. Okay, so a convolution. So think of a convolution as you have this filter, this kernel. Think of it also like your weight. And as it slides over your image, your response will be a feature map. And that will tell you how similar that portion of the input image is to your convolution filter. So if you have a vertical edge detector, you'll see that things that are close to a vertical edge will have the highest response, and things like that. You'll see things like that when you want to apply a convolution. So how do you define what the size is of your input filter? In in your network configuration, when you apply the text, this is what it looks like in Cafe and even in Digits too, because Digits works with Cafe. And so here's an example of what that will look like. You'll have a layer, so you'll define a layer. You'll give it a name. You'll define it as a convolutional layer, and then you'll define what its input-output information is. And then you can define its parameters. So before, when I showed you the schematic, I said that the number of outputs were 20 for this convolutional layer. Here's where you would specify that. And then here's where you'll specify your kernel size, being 5 by 5. And here's an example of a 5 by 5 kernel and what it would look like over this image. And what happens is the convolutional kernel slides over the image pixel by pixel, just like this. And then at the end, you have your feature map output. So I mentioned before, if you don't want your image, your feature map to reduce, because what will happen is your feature map will reduce by 2 times the radius of your kernel. If you don't want it to reduce, you could apply zero padding, which is just you would apply a perimeter of zeros around your input, and then apply the convolution, and then the output will be 28 by 28. So it's one thing you can think about, and you can do that in Digits too. If you're interested in doing that, or if you're looking for an example, when you select the AlexNet configuration, you'll see that when you select the AlexNet configuration. And you can also find that in the online documentation as well if you need, if you're looking for more examples or want more information about how that works. So network parameters. So I talked about when I said, okay, I want to add a layer, a new convolutional layer. I want to add pooling, and I'm going to add an activation function. So when I want to add this to my neural network, I'm going to add things to my customized window, to my text file that describes my neural network. And just like what I showed you in the previous slide, I'm going to define my layer. I'll define a name for it, and then I'll define the type of layer parameter I'm adding. I'll give it a name. I'll define what my input-output is for that layer. In this case, for the convolution, I'm pushing in my data, and then I'm going to push out my output, and I've titled it COM1 or COM0. You'll see that I've got my number of outputs defined here, just like before, and my kernel size. Then, if I want to push the output from that convolution to my pooling or subsampling layer, I'll have this COM0, and it'll be the bottom of my pooling subsampling. And just like when I define the convolutional layer, I define a layer, I give it a name, but then my type is different. So in this case, I'm pooling, right? And then I can decide my stride and kernel size here too as well. So then, now in this case here, I'm saying, okay, after pooling, I want to apply my data to an activation. And here's an example of a ReLU or rectified linear units activation function. But in some cases, you may find that you're not going to do this. You'll have pooling. After you're pooling, maybe you want to push your data through another convolutional layer instead of an activation, and you can definitely do that too. And what would happen is then you would have your the top of your pooling layer would go into another layer that would be defined just like convolutional 1, except the bottom specified pooling 0. The bottom will have the name of your pooling. So it's just like that. Think about this as this is a file that describes what you're doing with your network, but then you will always, one thing to keep in mind, I know this is a lot of text, one thing to keep in mind is that when you do this in Digits, you can always use the visualization feature in the network configuration to help you double check your network configuration. So here's where you can do that. So even if you select a standard network, you can select Customize, and it will take you right here to your custom network window. I showed you the network configuration earlier with the plot, and if you select Visualize right here on this window, it will post that for you. All that text, like those layer parameters, all of your pooling, that goes right into this Edit Text box if you want to edit this. If you don't want to edit your neural network, like maybe you're just getting started, you want to just try a standard network, no problem. You can still customize, select, visualize, and not edit your network at all and still train. It's just helpful. I find it always helpful to visualize my network configuration just to give me a feeling for what my network looks like. Okay, so here's an example. I showed you before examples of adding network parameters and all that text. Here's just another example. You can take this. Here's an example of just taking a convolutional layer, and this you could paste directly into your custom network, into your custom network window. One thing to keep in mind when you're pasting is make sure that you get your input-output information right. So if I put in like a convolution 5, or I put in a pooling, make sure I have the right inputs and outputs for that new parameter. And then after you do it, just always visualize it so you can see what your network looks like. Because so I'm like a repeat offender for just copying and pasting things, and I often forget or accidentally put in the wrong bottom and top, or the wrong bottom layer information. And so I'll always use visualize just to double check and make sure that that I correctly edited my network configuration. Here's another example of an activation function, rectified linear units activation function, and this looks exactly like the information in the edit box where you're going to edit your network. You could take this and just copy and paste it right into your edit box when you go through the exercise. Just keep in mind that you may need to change the name of your layer, and you may need to change what you have as the input and output, depending on where you want it to be. So if you added this to a convolution layer 2, you may want to have the bottom as your convolution layer 2 as the input output if you want this to work with that portion of the network. So here's an example of an error. I know I've talked a lot about looking at your network, trying to understand it, how you visualize your network, and what these parameters look like. So if you press the Visualize button on the previous slide, you'll get a schematic of your network that looks like this that I showed you before in the presentation. And after you edit, I always feel like, at least for me, I have to check my edit. So here's just the default Lynette network. And then on the example on the right, I have an example of some edits that I did. And what will happen is digits won't tell you that there's an error, right? But if you're familiar with what your network looks like and what you want it to look like, then you can say, oh, okay, I made a mistake. So in this case, I created a convolutional layer, and I labeled it conv3, and it's going nowhere, right? Also, my input data is going to 2 different convolutional layers, which I probably didn't want. And then the output for my convolutional layer 1 is going to 2 different poolings. So here's an example of where I would look at my layer, I would visualize my network, and I could say, oh, I made a mistake. I don't have the right inputs and outputs for this network. Let me go back and make my edits. If this happens and you just train anyway, a lot of times digits will just tell you that there's an error. It will output an error similar to what you would see if you were cafe alone. There are also some cases that we found where sometimes digits can hang. And in the lab, as part of this lab, you'll find a place in the lab where you can restart digits if that happens to you. So just as an FYI on that. But anyways, I usually use this to help prevent, to help catch any of my errors that I have in my network configuration when I'm customizing it. Okay, so I talked about editing your network. And the whole reason that I even modify my network is to try and improve performance, trying to get better accuracy from higher performance out of my trained neural network. I'll try adding a convolutional layer. I'll try increasing the number of outputs. I'll try reducing the learning rate. But in some cases, I don't really get the performance that I want. I want to improve the performance. And in some cases too, my training data is not a good representation or isn't the best representation of the images that I want, of the input data I want to classify when I deploy my neural network. So I have a simple example here. I have a data set comprised of an MNIST data set, and I have a white background with black digits ranging from 0 to 9, but maybe I would like to classify images that are digits but don't look very similar, or not well represented in this standard MNIST data set. So maybe I don't have enough. In some cases, you may not have enough of this type of data, so you can't add it to your current MNIST data set, in this case, MNIST data set. So sometimes you can augment your data, and you can augment it in a way that will provide or represent the input data you would like to classify. And there are a couple ways you can think about doing this. You could distort the images. You could add noise in some cases. You could change the color scheme. You could do a variety of different things. And so these are some things that I have done. In some cases with other trained networks, I've been able to just mirror my images and found like an improvement in performance. So it just depends on how you want to use your trained neural network once you're done with it. Once you've got a network that's trained effectively, then you have to think about, okay, well, I trained it based on this data. Is my training data a good representation of what I want to classify? Okay, so here's an example of augmenting my data. And I talked a little bit about it in the previous slide, but so depending on your deployment scenario, maybe a simple modification is all you need to improve performance. And in this case, I said, okay, well, maybe I could just invert my images. And I could say, okay, all of my images are, I have a handwritten digit in black ink and my backgrounds are white. Maybe I'm just going to try making inverted copies of all of my images so that I have a black background and a handwritten digit with white pixels. But there are other ways to augment the data and improve it, and I mentioned this in the previous slide, but I did mirroring. I've done mirroring before. You can do rotation to your data. You can apply noise. You can do stretching, color distortions, and there are a lot of easy ways to do this. You could use Image Magic. You could use Pillow. You can use OpenCV. There are a lot of tools out there to help you do this quickly if you need to, or if you want to test it out as well. So if you augment your data and do something and you do this, you can still use digits for it. So one thing to keep in mind is when you augment your data, you'll have this whole data set, right? And in some cases, in the example here, I have two versions of each image. I have my original and then I have an inverted copy. And what you don't want is you don't want the same image, the original and the inverted copy. You don't want it to exist in both your training and validation data, because you want to validate and test the accuracy of your trained neural network on data that it hasn't seen before. And so then you don't want to have the original data plus its copies, whatever variation you have on the original. You don't want that to exist in your validation data set. So you can still use digits to help you create a data set. And what you do in that case is now you're going to go, instead of going to the Use Image folder and just entering the path to where you have all your images with directories for your categories, you can upload text files. And you can upload text files with a list of all your training images, and you can upload a text file with a list of all your validation images. And this ensures that you don't mix up your training data with your validation data, or data that's intended for training with data that you intend to use for validation. So here's an example of how you would have your training data. Here's an example of what your text file will look like. I have a path to my training data, my category, my image name, and then I'll have my category number here. So in this case, it's a digit, an image of a digit 0, and then I have 0 at the end of my line to signify that this is for category 0. And then my validation text file follows the same thing, follows the same process where I have a path to my images, I have a space, then I have my category name. And then all I'm going to do is upload my text file here. Then remember that you need to upload a labeled text file. So you'll have a labeled text file, and the labeled text file will list, in this case, if I have digits ranging from 0 to 9, it will just be a list of my category names, where the first line will be a 0, the second line will be a 1, and it'll go through until 9. But if you had something where you were doing dog types, you would just have a list of those dog types. Just remember that the first category, the first line represents category 0, the second line, and so forth like that. Okay, so as part of your lab later, when you take the hands-on lab, we'll go through this you will go through this example of taking an augmented data set of inverted copies of the digits data set, and then you'll be able to classify images like this. And you can test classifying these images with and without the augmented data set to see how well and how this improves the performance of your trained neural network with data that may or may not have been a good representation of your original training set. So I'm running low on time. I have about 6 minutes. I have a few more slides, and I'll run through them really quickly. I talked a lot about figuring your neural network and making your neural network well suited for your data and making modifications and how you do that. So the next step is deploying your network. Once you have a neural network that you believe is working and effective and does exactly what you want to deploy it. In some cases, you may want to leave it on a host machine and test there. But in other cases, maybe you just want to take that trained neural network and deploy it somewhere else. Maybe you've got some servers, you've got something set up in the cloud, and you just want to perform classification on the fly with the neural network. You can download your model here, and you can deploy it on your other devices. And if you wanted to deploy it on the Tegra, if you want to do classification on the Jetson TK1, you can totally do that too. Digits makes it really easy. So all you have to do is select the model you want to download and then download it. It's really great that we have this model selection here because early in the presentation I talked about overfitting. So you can look at the plot and see whether or not you overfit your network. And if you overfit your network after epoch 12, you can download epoch 11 and then take that version of your neural network and deploy it on any of your devices. So I thought I'd have a slide in here that just talks about the Jetson because I tested my trained neural networks on the Jetson, and it's flexible. It's a low-power device. It's easy to use and GPU accelerated. So the only thing to think about here is once you deploy your neural network, remember you need to build your framework on the Jetson so that it can use those network files. With digits outputs, because digits works closely with Caffe, digits will output trained neural network files that are Caffe network files. So when you get on the Jetson, you'll want to build Caffe on that platform, and then you just port your trained neural network to that device. And if you use Caffe, you'll know you've probably tested out the web demo exercise. I've launched the web demo on the Jetson, and I have it set up on my home network, and I'll hit it from another device and launch it. And then just a couple resources. I know I've gone through a lot of information here. And a lot of information on tweaking and fine-tuning your network. I just wanted to make sure that I gave you guys a slide or showed you a slide that talked about resources for using digits. in addition to always being able to reach out to the deep learning group at NVIDIA directly and through this course, reaching out to us, you can always reach out to us through our Digits Users Google group, and you can ask questions there. If you want more information on documentation for how to use digits, you can use this presentation, but we also have other Introduction to Digits presentations you can access, and we have blogs. We also have a Getting Started guide to help you get started and help you go through the whole exercise of using digits for the first time on your own. And then we have the hands-on lab to help you get started too. So I mentioned the lab earlier in this presentation, and I talked a lot about modifying the network and using digits and how you use digits and to optimize your network and test performance. So you can go through this whole process too through a hands-on lab that we're offering. And how you access it is through nvidia.quicklab.com, and you can go to the Getting Started with Digits lab. So one thing that's nice about this is you don't need a GPU to get started with using digits. So if you don't have a system right now with an NVIDIA GPU in it, no problem. You can test out this lab and test out digits. And the lab is free until the end of this deep learning lab series. So this lab, this lab that we have right now and this discussion today is all part of our deep learning lab series. And this is class 2, but we also have 3 more classes coming up that I hope that you guys can participate in. We have the next one will be getting started. Oh, but another thing, we also have office hours. So before I get started talking about the other classes, I just want to mention that in addition to all the resources you have at your disposal for reaching out to us at NVIDIA on how to get started using digits and the documentation, there will also be an office hours next week. And you can ask questions about how to get started, issues that you're having, or even just questions about how to use digits and expand on it, or maybe build on other frameworks, like maybe you want to build on the AlexNet framework. You can ask your questions then. Then on the 19th, we'll have the next class. So, and the next class will be on getting started with Caffe. And then we'll have a class on getting started with Piano and getting started with Torch. And all of those classes also have office hours too. So you can use those office hours as additional opportunities to ask questions. And then there's more information at NVIDIA, at developer.nvidia.com, deep learning courses. And feel free to check out that link. We'll be posting all of the recordings and the presentations there and links to the lab. And I'm right at the top of the hour. So I'm out of time to ask questions. I can try and ask a couple before people start to drop off. And the first one is, does digits work on Windows? Someone asked that earlier. And so the only thing with digits and Windows, one thing to think about is digits works closely with the framework. So digits is a visualization tool, and it's a great interaction tool, and it sits on top of a framework. Right now it sits on top of Caffe. And one thing to think about is, okay, if I want to use Windows, I'm going to have to build Caffe on my Windows machine. And Windows is not officially supported by Caffe. There are some blogs about it, so you can try that, but you'll have to check out those blogs about how to do it and look into that. I haven't tested it though. As far as other Linux distros other than Ubuntu, people have tested it on like CentOS, so you can definitely give that a try. And there's another question about how big data sets need to be enough for training purposes. So it totally varies. So I've got a couple data sets where I've got like 20,000 images. I used ImageNet. So I totally use ImageNet to get a lot of my images. And I just download the URL list, and I'll just do wget the images from the categories of my interest. And I've done things where I did a shift type recognition approach, and I think I had about 20,000 images in total. That included both my training and validation set. I didn't get great accuracy using AlexNet. I got about 65% or 68% accuracy. So for that small data set, what I ended up doing was taking a pre-trained network, and I ported that into digits, and then I just fine-tuned it for my new data. So another question is digits for image recognition only? And right now it is. However, one thing I want to mention is there are a lot of, the whole thing with digits, the whole point of even having digits is we use it internally at NVIDIA for some of our efforts, and we open sourced it and provided it to the community because we thought it would be useful to other people too. And we want to continue to make it useful for us and the community. So right now it's only for image recognition and classification, but definitely engage with us and help us and give us feedback on things that you think are really important that would make digits more valuable to you, and we can put it on our list of priorities because we want to make sure that it not only stays valuable to us but also to you as a user. And can I use digits for other data sets other than images? So I haven't tested digits with other things besides images. I suspect you could probably do signal stuff, but I admit I haven't tested it. So maybe if you reach out to us through the Digits Users Group, I often answer questions there, and talk to us about your problem in more detail. We could see if maybe you can use digits for what you're trying to do. And I think that's pretty close to all the time I have. Thank you so much for participating today. If you guys with questions, please come back next week and ask questions. We'll try and address them all next week during our office hours. And thank you so much for your time today, guys.